define this, but one of the student has doubt about this probability density function and requested to explain me once again. So that's why today I am going to explain the definition of probability density function. This is nothing but a continuous probability function. For every x belonging to the range of a continuous random variable x, we assign a real number f of x satisfying the conditions. That first condition should be f of x greater than or equal to 0, and second one, integration over the limits minus infinity to infinity f of x dx equal to 1. If the function satisfies these two conditions where that x belonging to the range of random variables, then such function is called as continuous probability function, or we call it as a probability density function, that is a PDF. Whenever you are given with a function called PDF, then that automatically it means that f of x satisfies these two conditions, that function should be greater than or equal to 0, and integration over the limits minus infinity to plus infinity is always 1. And in the next, if the limits is particularly it is in interval, suppose if AB is a subinterval of the range space of x, then the probability that x lies in interval AB is defined to be the integral of f of x between a and b. That is, probability of x which lies between a and b is given by integral of f of x between the limits a and b. And similarly, as we defined a PDF, we define another distribution function that is called as a cumulative distribution function. This is nothing but a PDF only, that is if x is a continuous random variable with the probability density function f of x, then the function, this capital F of x, we denote it by capital F of x, which is defined by probability of x, that is a continuous random variable which is less than or equal to x, is given by integral of f of x dx varies from minus infinity to x, is called the cumulative distribution function, that is CDF of x. In the PDF, just observe limits are, it varies from minus infinity to plus infinity, while in the CDF it varies from minus infinity to x. So we restrict the limit here. So it is clear that from this above equation, it is clear that this cumulative distributive function f of x is equal to probability of x, a random variable x, which lies between minus infinity to x, and derivative of this cumulative function is always a PDF, that is f of x. So note, it should be noted that probability of a continuous random variable taking a particular value is 0, whereas the probability that it takes values in an interval is always positive quantity. So if R is any real number, then we can write probability of x greater than or equal to R is given by integral over R to infinity f of x dx. Probability of x less than R, it is given by 1 minus probability of x greater than or equal to R. That is, it's nothing but 1 minus x greater than or equal to R is what? It is the integral varies from R to infinity f of x dx. You may write this probability of x less than or equal to less than R as 1 minus p of x equal to R, or 1 minus integral over R to infinity f of x dx. So after studying all these two definitions, we can conclude that integration minus infinity to infinity, that is f of x dx, is 1. So this is nothing but it represents geometrically, it is meaning that it's the area bounded by the curve f of x, and x-axis is equal to the unity. Also, probability of x which lies between a and b is equal to the area of the region bounded by the curve f of x, the x-axis and the ordinates x equal to a and x equal to b. So this is the small elaboration about PDF and CDF. And one more question was been asked, that how to take consider the limits in PDF, finding the values. So in the previous examples, just to go through your previous examples, in the first example we examined that whether the given function is probability function or not. The given function is 3x when x lies between 0 and 1, otherwise it is 0. So this is the question. So since we have to examine whether the function is PDF or not, that should satisfy these two conditions, f of x greater than or equal to 0, and this integral varies from minus infinity to infinity should be equal to 1. So minus infinity to plus infinity means what? We can split this limit as minus infinity to 0, 0 to 1, 1 to infinity. So starting minus infinity ends at infinity. Why we split it like this? Because our given x, which lies between 2ab, our ab, that is open interval, sub interval is given between minus infinity to plus infinity. That sub interval is 0 and 1. So we splitted this minus infinity to plus infinity including this sub interval. So minus infinity to 0, 0 to 1, 1 to infinity. So now minus infinity to 0, our function is 0 because otherwise it is 0. Function takes only 3x between 0 and 1. At remaining interval it should be 0. So that's why it is 0. From 0 to 1 it is 3x. Again x is up to only 1. So from 1 to infinity again function takes the value 0. So like this we have to split the interval and we have to consider the interval for the PDF. Same as here for the second example, we have to modulus of x, that mod x is less than or equal to 1. So again function should be greater than or equal to 0. This minus infinity to plus infinity is taken as minus 1 to plus 1. Again minus 1 to plus 1 is split as minus 1 to 0, 0 to 1, because at the remaining cases function is 0. In the same way, in the third example also, we are mentioned with x lies between 0 to 3, between 0 and 3, otherwise it is 0, the main function. And also they asked you to compute x when probability of x when it lies between 1 and 2, and probability when x is less than or equal to 1 and when it is greater than 1. So first we found for 0 to 3 what should the function should be equal to 1, so we found k. Then probability of the function when x lies between 1 and 2 means limits is from 1 to 2 only. So limits are already mentioned, interval is mentioned, so it should be 1 to 2. At 1 to 2 function takes the value kx square. K we already found, so we took it as 1 to 2. When it is x less than or equal to 1 means what? Less than or equal to 1. So maximum value is 1. Minimum is it's lower than this. So that should be 0 here. So interval should be taken as 0 to 1. In the same way for x greater than 1 means what? Greater than 1. What is the maximum limit for our x is given here? It is up to 3. For remaining it is 0. So function is from greater than 1 means 1 to 3. 1 to 3 function is kx square again. So like this we have to take the intervals while finding the PDF. Now we'll move on to next example, that is find the CDF for the following PDF of a random variable x. That is, find the cumulative distributive function for the following probability density function of a random variable x. First function is f of x equal to 6x minus 6x square while x lies between 0 and 1, otherwise it is 0. Second question is function is x by 4 into e raised to minus x by 2 when x lies between 0 and 2 infinity, otherwise it is 0. Third, we need to find exponential distribution. So solution: if f of x is the PDF, then the CDF according to our definition of CDF, what is that? It is nothing. It is a PDF which varies from minus infinity to x, f of x dx. So then for the first example, we need to find a CDF. So then its CDF becomes now f of x is equal to minus infinity to x, f of x dx. But minus infinity to, how will you split this? 0, f of x dx plus 0 to x, f of x dx. But minus infinity to 0, our function is 0. So it is 0. From 0 to x, we left out with 0 to x, f of x dx. So this is from 0 to x, f of x, our function is 6x minus 6x square dx. So when you integrate this, you will get 3x square minus 2x cube, limits varies from 0 to x. So function, cumulative distributive function is 3x square minus 2x cube if x lies between 0 and 1. We are finding the function, not its value. So CDF of the given PDF is 3x square minus 2x cube for the first example. Then for the second example, our CDF f of x becomes again is 0 to x, f of x dx, as we did in the previous case. Directly I will write the function, because here also it is 0 to x lies between 0 and infinity. Between 0 to infinity, function is x by 4 e raised to minus x square. So from 0 to x, it is x by 4 e raised to minus x by 2 dx. So integration by parts. Integration by parts. What will you get? It is take 1 by 4 outside. Now integrate it by part. X into e raised to minus x by 2 minus 1 by 2 minus integration of integration 1 into e raised to minus x by 2 by 1 by 4. 0 to x. So 1 by 4. So it is minus 2 x into e raised to minus x by 2. I am going to substitute the limits. Minus 4 e raised to minus x by 2 minus 1. So this gives us CDF. So when you simplify and open this bracket, minus 2 plus 1 minus e raised to minus x by 2 into 1 by 4. So it is e raised to minus x by 2 minus this x by 2 e raised to minus x by 2. If x lies between 0 to infinity. Therefore, CDF is equal to 1 minus e raised to minus x by 2 minus x by 2 into e raised to minus x by 2. If infinity. Third, they asked you to find exponential distribution. Exponential distribution, we have a standard formula for the exponential distribution. That is, when you say function is exponentially distributed, then it is given by alpha into e raised to minus alpha x, where x lies between 0 to infinity. Otherwise, it is 0. So is the PDF of exponential distribution. We need to find CDF of this exponential distribution. That is a cumulative distributive function. Then that is given by f of x. It is minus infinity to x, f of x dx. So this is nothing but 0 to x, because our minimum value is 0 here. So 0 to x, f of x dx. So it is 0 to x, alpha into e raised to minus alpha x dx. So integrate this, so we will get minus minus e raised to minus alpha x 0 to x. So it is 1 minus e raised to minus alpha x. Therefore, CDF of exponential distribution is 1 minus e raised to minus alpha x if x lies between 0 and infinity. CDF of a PDF of exponential distribution. So next example. Next example. The sales per day in a shop is exponentially distributed with the average sale amounting to rupees 100 and net profit is 8%. Find the probability that the net profit exceeds rupees 30 on 2 consecutive days. Solution. So what they asked, the sales per day in a shop is exponentially distributed with the average sale amounting, that is for rupees 200. Net profit will be 8%. So we need to find the probability that the net profit exceeds rupees 30 on 2 consecutive days. For each 2 consecutive days, the net profit should exceed 30 rupees. So let us denote this random variable by x, which is random variable represents the sale in the shop. So let x be the random variable of the sale in the shop. Since x is an exponential variate, the PDF f of x, that is a probability density function, is given by alpha into e raised to minus alpha x, x greater than 0. So mean for exponential distribution is 1 by alpha, that is 1 by 100 here. Therefore alpha is 0.01. Hence f of x is 0.01 e raised to minus 0.01 x, where x is greater than 0. Why we took alpha as 100? Because here we when given with exponential distributed, that average sale, it's a average sale is rupees 200. So that's why it's considered as mean. So let A be the amount for which profit is 8%. So this implies A into 8 by 100, that is equal to 30. That because our requirement is profit should and net profit is 8%, and we need to exceed this by rupees 30. So A into, therefore A is equal to 375. So now we need to find probability of profit exceeding rupees 30 is equal to 1 minus probability of profit is less than or equal to rupees 30. Exceeding means what? We need 1 minus less than or equal to 30 gives us the probability of profit exceeding 30. So it is 1 minus probability of, to get profit less than or equal to 30 means what? Sales less than or equal to rupees 375. So this is nothing but 1 minus, it is 0 to integration 0 to 375, function is 0.01 e raised to minus 0.01 x, that is our PDF, into dx. So this is equal to, while you integrate 1 plus e raised to minus 0.01 into x over the limit 0 to 375. When we simplify, we'll get it as e raised to minus 3.75. So the probability that profit exceed rupees 30 on a single day is e raised to minus 3.75. Then we need to find it for 2 consecutive days. So thus the probability that it repeats on the following day is e raised to minus 3.75 into e raised to minus 3.75, which is e raised to minus 7.5, which is nothing but 0.00055. This is the probability of the net profit which exceeds rupees 30 for each consecutive days. In the next class, I am going to start next distribution, that is a normal distribution. Thank you.